So in this video, I am going to cover some problems that could be on your exam next week if you're in my class. This exam will cover limits. It will cover limits algebraically, graphically. We will look at continuity and the formal definition of a derivative. So let's get started. For our first problem, looking at the graphs of f of x, answer the questions about the function. So first we want to figure out what is f of -3. So you're looking at what is the y value when x is -3 on the graph. So looking at this, when x is -3, we get that our y value is 4. Now we want to look at the limit as x is approaching -3. It doesn't have from the left or the right. And so we want to make sure that the left and the right are coming into the same y value as we get closer and closer to x equals -3. And I can see as I get closer and closer to x equals -3 on the left and on the right, my y value that I'm getting is 4. For the second graph, when I look at f of -3, notice that there's an open circle where x is -3, and there's no solid circle above or below. So f of -3 in this example does not exist. But as we are approaching x equals -3 on the left and the right, we are getting closer and closer to the y value here of 4. So the limit does exist, and it's equal to 4. For the third graph, we're looking at f of -3. F of -3 on that parabola shape on the vertex is an open circle, but we do have a closed circle below here. And so that is the y value when x is -3, and the y value when x is -3 is 1. Again, looking at the limit as x is approaching -3, we are coming into the same y value, getting closer and closer to that y value of 4 as x gets closer and closer to 3. So the limit as x approaches -3 is 4. The fourth graph, it says, what is f of -3? So notice there is a jump in the graph when x is -3. And we're looking for the solid circle, and the solid circle when x is -3 is 1. If I'm looking at x is approaching -3 on the left-hand side, I get 4. And x is approaching 3 on the right-hand side, I get 1. Since the limits are not approaching the same value on the left and the right, then we say that the limit as x approaches -3 does not exist. That last graph, f of -3, I see I have a solid circle when my y value is 2. Again, as I'm looking as x is approaching -3 on the left, I get 4. On the right, I get 1. These are not the same value, so the limit does not exist. Pulling up the next question. Sketch a graph of a function f that satisfies all the conditions. So first of all, it gives us that f of -2 is 5. So that's telling me I have a point on the graph when x is -2, my y value is 5. I get, though, that the limit as x is approaching -2 is 1. So I know that I'm going to have an open circle at -2, 1. And I'm going to be getting closer and closer to this on the left and the right. I'm not sure if I'm increasing to that value on the left or if I'm decreasing. I'll come back to that in a minute. I'm going to put a little star on here that I need to come back and look at this. It says here the limit as x is approaching 4 on the right is 3. Okay, so as I'm coming in to x equals 4, on the right-hand side, I'm getting a y value of 3. Let's go back down. I need to figure out and follow all these conditions. So I'll come back to that just to make sure that it follows the conditions below. Tells me f is increasing on x less than -2. Okay, So I know that x is increasing, so I will be coming up as I approach x equals -2. And I know it doesn't say that my limit was 1, so I actually did the wrong thing there. So I'm increasing until I hit x equals -2. Okay. So we might be decreasing here for a little bit. The limit as x is approaching -4 of f of x is less than the limit as x is approaching 4 from the right of f of x. So this is telling me that my y value for x is between, well, 4 on the left is going to be smaller than the y value as I approach 4 on the right. Okay, so let's come back over here. It says the limit as x is approaching 4 on the right is 3. So that works. F is increasing on x is less than -2. So I have that. I have it increasing other places, but it doesn't tell me that that's the only place where it's increasing. So I believe my graph is okay there. And the limit as x is approaching -2 is equal to 1 when f of -2 was 5. So here is an example of a graph that satisfies all of those conditions. Okay, so the next example, use the graph to answer the following questions. First question says, look at the limit as x is approaching 1 on the left-hand side of f of x. So locate x equals 1 on the graph. Coming in on the left-hand side, so following the graph on the left-hand side, I see that my y value I am approaching is 4. So limit as x approaches 1 on the left is 4. F of 1. So I have an open circle on that graph, and below that open circle is a solid circle. And so my point when x is 1 is actually 2. Now I'm looking at the limit as x is approaching 1 on the right-hand side. So locating x equals 1, following the graph on the right-hand side close to x equals 1, I see the y value that I'm getting closer and closer to is 4. Since the limit on the left and the right are equal to each other, the limit as x approaches 1 is 4. Now we're looking at the limit as x is approaching -2. So located x equals -2 on our graph. And it's saying the limit as x approaching -2, it doesn't say left or right. So I need to make sure that the left-hand side, I see that it is approaching -2. On the left is not the same as we're approaching -2 on the right. And so this limit does not exist. F of -2, I notice I have a solid circle right here at -2, -2. So f of -2 is -2. If I look at the limit as x is approaching -2 on the left-hand side, we saw that that was getting closer and closer to y equals -2. Approaching x equals -2 on the right-hand side, I see that the y value I'm getting closer and closer to is 2. Next question asks, the limit as x is approaching 3. Again, it doesn't say left or right, so I need to make sure the left and the right-hand side are approaching the same value. Locate x equals 3 on the graph. Coming in on the left-hand side, I have a y value of 2. Coming in on the right-hand side, I also am getting closer to that y value of 2. So that limit is 2. Next question asks, is f prime of 2, so the derivative of our function f of x at 2, positive or negative? Explain your answer. So looking at x equals 2, I want to see, is my graph increasing or decreasing at that x value? And so looking at x equals 2, I notice my graph is decreasing here. And so since my graph is decreasing, I know my slope is negative. And so f prime of 2 is negative. I explain my answer. I'm not going to write that down. Where does f of prime of x equal 0? Okay, so that's where our derivative is equal to 0. That's where our slope is equal to 0. I see that there's one value where our derivative is going to be 0, and that's what this local minimum right here when x is -3. So I know that the derivative of f of x is 0 at x equals -3. In this case, what does this mean? This means that my slope again is 0 there. And in this case, I have a minimum value at x equals -3. Where is f of x not differentiable? Where does, in parentheses, where does the derivative not exist? So remember, the derivative does not exist at jumps on our graph. And I notice I have a jump on our graph at x equals -2. So the derivative does not exist at -2. And it is where we have sharp corners. And so that's going to be here. Well, it's actually undefined at x equals 1 for that. Well, it is defined, it's at 2. But there is a sharp corner there, and there's a jump in there. So at x equals 1, the limit or the derivative does not exist. Here's another place. It's undefined when x is 3. So the derivative is not going to exist there. I think I skipped one. Is f of x continuous at x equals 1? Explain your answer mathematically. So x equals 1 is not continuous because I know that the limit as x is approaching 1 of f of x is 4. But the limit as x is approaching 1 needs to also equal f of 1, and it doesn't equal f of 1. F of 1 in our case, we saw was equal to 2. So one of those conditions for continuity does not hold true. Okay, so the next problem we have is find the limit of the following functions. If it does not exist, show why. We're showing these algebraically. We're looking at the limit as x is approaching -2 of x squared minus 5x minus 6. So what we want to do if we're looking at this algebraically is we want to go in this case, we have our variable x. We want to go in, put parentheses wherever we see an x. And we're going to replace x. So our parentheses, we're going to rewrite -2 because that's where the limit is approaching. Now let's simplify using order of operations. So -2 quantity squared is +4. And -5 times a -2. So we're going to add 10 minus 6. So 4 plus 10 is 14 minus 6 gives me 8. So limit as x approaches -2 of that function is 8. So I'm going to do the same thing for the next example. The limit as x approaches -3 of x squared minus 9 all over x squared plus x minus 6. First, always go through and do direct substitution. And if we get an indeterminate form, then we're going to have to go back and manipulate. And so notice when we go in here, put parentheses wherever you see an x. And then we're taking the limit as x is approaching -3. So inside our parentheses, we're going to replace that with a -6. I'm sorry, not a -6, a -3. So order of operations, simplify our numerator. Exponents come first. -3 quantity squared is 9. 9 minus 9 gives me 0. In my numerator, all over -3 squared again is 9, minus 3 minus 6 also gives me 0 in my denominator. And this is an indeterminate form, which tells me I don't know anything about my limit as x is approaching -3 here, and I need to go back and manipulate what I'm taking the limit of. And in this case, I would factor. And so I'm going to bring down the limit because I haven't taken the limit yet. As I go back in and manipulate this, I see I have a difference of squares, x squared minus 9. That can be factored as x minus 3 times x plus 3. All over x squared plus x minus 6. I notice there are two numbers that multiply to give me negative 6 and add to give me a positive 1. And that would be a positive 3 and a negative 2. And so the denominator factors as x plus 3, that quantity times the quantity x minus 2. So notice that we have like factors in our numerator and denominator, and we can cancel those out. So x plus 3's cancel. Now I'm going to go in and I'm going to do direct substitution. Wherever I see an x left, I'm going to replace it with negative 3. So doing so, now I'm taking the limit. I'm not going to bring down that limit anymore. And I'm going to write negative 3. I see an x there, then minus 3, all over, I see an x, so negative 3 minus 2. Negative 3 minus 3 is negative 6, all over negative 3 minus 2, which is negative 5. I notice a negative divided by negative is positive, and so I can rewrite this as 6/5. The next example is a piecewise function. And I'm looking at the limit as x is approaching negative 2. So our equation changes when x equals negative 2. And so I want to see what's going on the left and what is going on the right of x equals negative 2. So looking at the limit here, as x is approaching negative 2 on the left-hand side, so these are values where x is less than negative 2, I'm going to use my first equation, 1 minus 2x. Doing direct substitution, I would have 1 minus 2. I see an x there, replace it with negative 2, and I get 1 plus negative 2 times negative 2 is positive 4. So 1 plus 4 gives me 5. Now let's look at the limit as x is approaching negative 2 on the right-hand side. And so these are values which are a little bit bigger than 2. So I would use equation 2, in this case, x squared plus 1. If I go in and I do direct substitution, I would get negative 2 squared plus 1. Negative 2 quantity squared is 4, and 4 plus 1 gives me 5. And so I see that the limit as x is approaching negative 2 on the left and the right is the same exact value. So I can say that the limit as x is approaching negative 2 of our piecewise function, f of x, this is going to equal 5. The next question says, is f of x continuous at x equals negative 2? Why or why not? So the limit part of the continuity being continuous holds. The next thing that has to hold is if we looked at f of negative 2, this should be the same value as our limit to be continuous. Well, I'm looking at that second equation because it says for x is greater than or equal to negative 2, and x is equal to negative 2. So plugging it into the second equation here, this would equal negative 2 quantity squared plus 1, which is equal to 5. So since our limit exists, our limit as x is approaching negative 2 of f of x is equal to f of negative 2. This is continuous. Our next example, we're looking at a limit as x is approaching negative infinity of x squared minus 2 all over 4 minus x cubed. So recall when we're looking at limit, it says x is approaching positive or negative infinity of a rational function. We look at the variable in our denominator to the highest power, in this case is an x cubed. And we're going to go through, we're going to multiply this by a fancy one. And that fancy one that we're choosing is 1 over the variable to the highest power in the denominator. So 1 over x cubed, all over 1 over x cubed. So if we distribute this in the numerator, so pulling down the limit because I haven't taken it yet, x squared all divided by x cubed minus 2 all divided by x cubed. And this is divided by 4 over x cubed minus x cubed divided by x cubed. So using my rules of exponents and dividing, have the same variable. If I'm dividing, I can simplify x squared over x cubed as 1 over x. Minus nothing simplifies for the second fraction in that numerator, so minus 2 over x cubed, all over 4 over x cubed, minus x cubed divided by x cubed is 1. So recall that if we have a limit as x is approaching either positive or negative infinity of some number over a variable x, and this is going to be going off to a 0. So I know that that 1 over x is going to be approaching 0, minus 2 over x cubed as x goes off to negative infinity, that will also be approaching 0. That 4 over x cubed as x goes off to negative infinity goes to 0, and then minus 1. So technically I have 0 over negative 1, which is equal to 0. Next problem says, consider the graph of the following of the function f of x on the interval 0 to 5. Part A, for which values of x with the derivative f prime of x not exist. And again, they don't exist at sharp corners. And so I look at x equals 2. There's a sharp corner there, so it's not going to exist at x equals 2. And I also have a sharp corner at x equals 4. Looking at the graph, we want to graph the derivative function. So noticing this first piece, as x is going from 0 to 2, it's a line, so the slope is the same everywhere on that line. So let's just look at a couple points on these lines. So if I'm going from 0, x equals 0, negative 1 to x equals 1, 0, let's think about our slope. So we're rising up 1, and then we are running over 1. So I know that my slope from x equals 0 to x equals 2 is 1. Okay, so I'm going to have a horizontal line from 0 to 2 of 1. Now looking from x equals 2 to 3, my slope in here is 0. So from 2 to 3, my slope is always 0. So I have this line segment from 2 to 3. And then from x equals 3 to 4, I notice my line is decreasing. Again, I want to figure out what is my slope there, just so I can see some points. It looks like it's crossing here. Looks like here. So let's look at this. This is at y equals 1. I'm falling 1, so negative 1. And I'm running over, these tick marks are in terms of a half. So my slope is negative 1 all over 1/2, which is equal to negative 2. So my slope from x equals 3 to 4, my slope is -2. So a horizontal line from x equals 3 to 4 at -2. So notice I have been putting open circles on those values, and that's because our derivative doesn't exist at those sharp corners. So, and we're graphing these derivative functions. So we want to put an open circle there, meaning it's not included. And then the last piece that we're looking at, I see that my graph is increasing from x equals 4 to x equals 5. I'm looking at some points here. So this would be x equals 1 or y equals 1 down here, and a point right here. So if I'm increasing 1, I'm running over a half. So 1 over 1/2. This is the same thing as 1 divided by 1/2. If you didn't see it, see how I got the other piece. Dividing with fractions, you take the first number times the reciprocal of the other. So this was 2. So I know that the slope everywhere from x equals 4 to 5 is 2. So this is what the graph of my derivative function would look like given the function above. Our next example, the revenue in dollars generated from selling X items is given by R of X equals 54 minus X squared all over 200. We want to find the marginal revenue, which means that we're looking for R prime of X, or the derivative of our revenue function R of X. We don't know the shortcut of taking derivatives yet in this class, so we're going to look at the formal definition of a derivative. And so we're looking here at the limit as h is approaching 0 of r of x plus h minus r of x all over h. So limit as h is approaching 0. So wherever I see an x in my r of x, I'm going to drop in x plus h. So here I have 54 minus x plus h, and then that quantity is squared, and that x plus h quantity squared is over 200, minus my r of x function. So I need to subtract everything off, so put brackets or parentheses around that whole function, 54 minus x squared over 200, all over h. So let's simplify this. So I have 54 minus, I am going to expand x plus h times x plus h. If you do that in my numerator, I would get this x squared plus 2xh plus h squared all over our 200. Let's distribute a negative sign here. And so this would give me minus 54 plus x squared over 200 divided by h. I notice that my 54 minus my 54 is going to cancel. I also notice that I have like terms, or sorry, not like terms, I have a common denominator of 200. This negative here is going to have to be distributed to each term. So in my numerator, I would have negative x squared minus 2xh plus h squared. And then adding the other fraction, so plus x squared all over 200 divided by h. So notice again, I have a negative x squared and a positive x squared, so those are going to cancel. I don't like that I have a fraction within a fraction, so I'm going to invert multiply my denominator. So over here, so I'm wondering. So in doing so, I have the limit as h goes to 0 of negative 2xh plus h squared, all divided by 200, times 1 over h. Notice we have common factor of h in our numerator. And so we can factor out that h from both of those terms in the numerator. And factoring out the h, I'm left with negative 2x plus h all over 200 times h. My h's cancel in the numerator denominator because it's a product. So now I have the limit as h approaches 0 of negative 2x plus h all over 200. Now doing direct substitution, plugging in 0 wherever I see an h in this, I'm left with negative 2x all over 200. So I got that my derivative function of my revenue, r prime of x, I'm going to simplify this, 2 and 200 both have 2 in common. This would be negative x all over 100. Estimate the revenue from the sale of the 4,000 first item being sold by finding r prime of 4,000. Well, we just found our derivative function, so we're evaluating our derivative function when x is 4,000. So I have negative, plugging in 4,000 here, all over 100. So it looks like we're losing money when we are producing that 44,000 first item. To determine the actual cost of the 4,000 first item, we are going to look at our revenue function, which is what we were given up here. And we're looking at the revenue of the 4,000 first item minus the revenue of making the 4,000th item. So we have 54 minus 4,001 quantity squared over 200 minus, put brackets around the whole thing, 54 minus 4,000 quantity squared all over 200. So doing that, distributing my negative, I notice my 54s are going to cancel. And I really have negative 4,001. The negative is outside, so first square 4,001 and then multiply by that negative 1 all over 200 plus, because minus a negative is plus, 4,000 quantity squared over 200. So if I look at 4,001 and square it, I get 16,008,001 all over 200 minus, so if I square 4,000, well, 4 times 4 is 16, and then I'm going to have 6 zeros. So that gets me 16 million over 200. We have a common denominator. So let me look at that 16,008,001 minus 16 million. That gives me 8,001 all over 200, which is equal to 40.005. If I round it up to the nearest cent, that would be $40.01. So the last part says compare our answers, B and C. What do you find? We find that the derivative function is a good estimate on finding the revenue of the 4,001st item. To the exact answer of what that would cost. The next problem in this review says let f of x equal to the square root of x. Answer the following questions. Use the limit definition of a derivative to find f prime of x. Okay, so looking at this, I'm looking at the limit as h goes to 0. F of x plus h. So plugging in x plus h wherever I see an x in my function, I get the square root of x plus h. Minus f of x, so minus square root of x, all over h. I notice when I do direct substitution, I get square root of x minus square root of x, which is 0, all over 0. 0 over 0 is an indeterminate form, and so we need to go back and manipulate. If you have radicals in your rational expression that you're taking the limit of, then you want to clear the radical by multiplying through by the conjugate. We're going to multiply that fancy one. That fancy one is going to be the square root of x plus h plus square root of x, all over the square root of x plus h plus the square root of x. I'm using the fact that if I multiply a difference, a minus b times a plus b, this is the difference of square, a squared minus b squared. And that just helps me. So when I go through, I don't have to really distribute it. I can just say, okay, well, this is the same thing as x plus h quantity squared minus the square root of x quantity squared, all over my h. Don't distribute in the denominator. If you do, you're going to have to factor. So now I'm looking at the limit as h is going to 0. Squaring a square root cancels the radical, leaving us with what's underneath the radical, which is called the radicand. So I have x plus h minus square root of x squared is just x, all over h times the square root of x plus h plus the square root of x. Notice we have x's cancel. So really I have a like factor in the numerator denominator of an h. Those h's are going to cancel out. So now when I'm looking at the limit here, as h is going to 0, of 1 all over the square root of x plus h plus the square root of x, going in there wherever we see an h, we're replacing it with 0. I'm going to drop my limit because I am taking it right now. So 1 over the square root of x plus the square root of x is 1 over 2 square roots of x. And this is the derivative function of f of x. So f prime of x is equal to 1 over 2 square roots of x. Part B says find the equation of the tangent line at x equals 9. Okay, so I need to figure out what my point is when x is 9, which means I need to find f of 9. So remember f of x is equal to the square root of x. So f of 9 is equal to the square root of 9, which is 3. So I know I have a point when x is 9. my y value is 3. So to find an equation of a line, we need a point and we need a slope. We know the slope everywhere on the square root of x where it exists. We're going to find the slope exactly at x equals 9. So we're going to evaluate our derivative at 9. So this is equal to 1 over 2 square roots of 9. So this is equal to 1 over 2 times 3, which is equal to 1/6. So my slope of my tangent line is 1/6. And my point on that tangent line is 9,3. So you can use your point slope formula. And I tend to use my slope intercept form to find my intercept. And I know a point at y is 3 is equal to my slope. My slope that I have here is 1/6 times x when y is 3, which is 9, plus b. So 3 is equal to, I see 9, 6 reduces. They would both, 9 and 6 both are divisible by 3. 3 goes into 9 3 times. 3 goes into 6 twice. So that reduces to 3/2 plus b. I notice when I subtract 3/2 to get b by itself, I'm going to need a common denominator, which is 2. So I have 6/2 minus 3/2 is equal to b. So my b value here is equal to 3/2. So knowing my y-intercept, knowing my slope of the tangent line, I can find the equation of the tangent line. Y is equal to my slope, 1/6, times x plus b, so plus 3/2. So that's the equation of the tangent line at x equals 9. The next problem says, suppose the volume of a water tank for 0 is less than or equal to t is less than or equal to 6 is given by v of t equals 10 plus 5t minus t squared cubic inches after t hours from 12 p.m. Find the instantaneous rate of change of v of t. So that is telling me I want to find the derivative function of v of t. So again, we haven't learned the shortcuts on taking derivatives, so I'm going to need to use the formal definition. I'm looking at the limit as h is approaching 0 of v of t plus h. So plugging in t plus h wherever I see a t in my v of t function. I have 10 plus 5, I see a t, so plug in t plus h. Minus, I see a t squared, so plug in t plus h, and that quantity is squared. Minus my v of t function. That negative is going to have to be distributed to each term in v of t. So put a bracket around your v of t function all over h. So let's expand. We have 10 plus, I have a 5 distributed to the t plus h, which would give me 5t plus 5h, minus, I'm going to expand t plus h times t plus h. Doing that, I would get t squared plus 2th plus h squared. Let's distribute our negative. So negative 1 times 10, so minus 10. Negative 1 times 5t is negative 5t or minus 5t. And negative times negative is positive plus t squared all over h. I notice a couple things are canceling out. I have a positive 10 and a negative 10. I have a positive 5t and a negative 5t. I'm going to need to distribute my negative 1 inside this parentheses here. So let's bring down what we haven't done yet. So I still have this 5h here in the numerator. Distributing my negative, I get a negative t squared minus a 2th. Minus an h squared. And then I also have a positive over here, t squared, all over h. So I notice my negative t squared and positive t squared cancels. I also notice in my numerator, all the terms that are left have an h in common, so I can factor out an h from the numerator. So let me bring down my limit because I haven't taken it yet. So limit as h goes to 0, h times the quantity of 2t minus h. Oops, and I forgot my 5, so let's just do plus 5 over here. All over h. So h is canceled. Now I can go in and do my direct substitution, plugging in a 0 wherever I see an h, what I'm taking the limit of. So this would give me 2t plus 5. So that is the instantaneous rate of change of my volume. So v prime of t is 2t plus 5. And the next problem, let me bring this down. Maybe it won't come down. Okay. So now, is the volume of the air increasing or decreasing at t equal 4? Interpret your answer. So we're going to look at the derivative, because we're wanting to know if it's increasing or decreasing. That's a rate of change, which we just found. So we're going to look at v prime of 4. So this would give us 2 times 4 plus 5. 2 times 4 is 8. 8 plus 5 gives me 13. This number is greater than 0. So I know my volume is increasing at t equals 4, which is 4 p.m. So it was t hours after noon. And it tells us what is the rate that it is increasing, which is 13. And I got to go back up to see what this was. This was cubic inches. So it is increasing at a rate of 13 cubic inches at 4 p.m. is what that is saying. So if you're in my class and you took this as a practice exam, you were supposed to watch this video and grade your exam and upload your graded version. What I'm looking for your graded version is that you put your score over the amount of points possible. So going through and counting up how many points each problem was worth, it looks like this test or review is out of 88 points. So while you were grading, you should have determined how many points that you had gotten for each piece that you had done, sum up how many points you got for each piece, and put that over 88. Make sure that you put that on the top of the first page of your graded review. I hope this was helpful.